Hello, children. A very good morning to all of you. Welcome back to the physical science class. From the past few weeks, we have been learning about the chapter force and pressure. Now, let us recall what we have learned in the previous class. The first thing we have learned in the previous class is that pressure is nothing but the force acting on a unit area of a surface. And then we have also learned the formula P is equal to F by A. And then we have also learned the unit of pressure is Pascal. And then we have also learned when the pressure increases or when the force increases, the pressure increases. Or when the force decreases, the pressure decreases. When you come to the area of contact, when the area of contact increases, the pressure decreases. And when the area of contact decreases, the pressure increases. We have also learned that solids exert pressure on an object. And we have also learned in liquids that liquids exert pressure on the bottom and on the sides of the container. We have learned that liquids exert pressure at the same depth equally. And we have also learned that as the depth increases, the pressure also increases. And the last thing which we learned in the last class was gases also exert pressure on the walls of the container. And today we shall start the class with another term which is atmospheric pressure. Children, we know that we have air all around us, is it not? Yes, we know. There is air all around us. Now, this envelope of air which is surrounding the earth is called as atmosphere. What is it called as, children? It is called as atmosphere. Now, this pressure which is exerted by this atmosphere is called as atmospheric pressure. You have studied about liquid pressure, the pressure exerted by the liquids. Solid pressure, pressure exerted by the solids. Gaseous pressure, the pressure exerted by the gases which is within the walls of the container. Now we are talking about atmospheric pressure. This is also air pressure, children. But we are talking about the atmospheric pressure, the pressure which is caused by the air which is outside a container or outside. From the outside is called as atmospheric pressure. Now, so the envelope of air around us is known as atmosphere, and the pressure exerted by this air is known as atmospheric pressure. Let me show you one small box. Okay, yes, we have taken a box which has a unit area, and here what is happening, the force which is acting on it is the atmospheric pressure, which means it is acting from the outside. Now here are too many molecules, children, air molecules. All these are the air molecules. We didn't pour anything into it. These are the air molecules. When there are larger number of air molecules, the pressure is more. The pressure is more if the number of air molecules is more. And here, where the number of air molecules are less, the pressure is less. Is that clear, children? So, we know that atmospheric pressure is the pressure exerted by air. And when the air molecules are less in number, the pressure exerted is less. When the air molecules are more in number, the pressure exerted is more. Okay. Now, if you move on, children, there is an instrument which is used to measure this atmospheric pressure. It is called as the barometer. What is it called as, children? Barometer. That is why this atmospheric pressure is also called as barometric pressure. Okay, children, it is also called as barometric pressure. Now, just now, what did I say? I said that atmospheric pressure is the air pressure which is exerted by the weight of air present in the atmosphere, which means air has weight, is it not? We know that air has weight. Yes. So, because of the weight of the air, the pressure which is caused is called as atmospheric pressure. So, the weight of air in a column of unit area is called as atmosphere. Now, let us look at a small example, children. Do you remember this picture? Let me explain. So, take a glass tumbler, okay, and then pour some water into it. Children, you have to pour water till the brim of the glass tumbler. Till the brim of the glass tumbler. Now, cover it with the help of a cardboard sheet. Cover it with the help of a cardboard sheet. Now hold the cardboard tightly and invert the glass tumbler holding the cardboard. Now what do you have to do, children? Slowly remove your hand which is touching the cardboard. Slowly remove your hand. What happened, children? What happened over here? Do you see that the cardboard is not falling down and the water is not spilling? Usually, if you hold it like that, the water is supposed to fall down. Is it not? But it is not falling down. So, in this experiment, what is happening? We have the liquid pressure from the inside and the atmospheric pressure from the outside. What do we have, children? We have liquid pressure from the inside and atmospheric pressure from the outside. And because of the air pressure pushing it up, the air pressure is pushing it up, children. The air pressure is pushing it up. And the liquid pressure is pushing it down and the air pressure is pushing it up. You have a cardboard over here. When it is inverted, how does it look like? It looks like this. Yes, and you have a cardboard. Let us assume this to be the cardboard. So the air pressure is pushing it in the upward direction and the liquid is pushing it in the downward direction. But because the air pressure from the outside or the atmospheric pressure from the outside is greater than the liquid pressure which is on the inside, what is happening, children? It is not falling down. But remember, children, the cardboard will stay only for a while because the cardboard becomes saturated, it becomes wet after some time, and now after it becomes wet, it will eventually fall down. Okay, right. Now let us look at the next part. What is this, children? It is an aeroplane. It is an aeroplane. Now, what is happening here? There is air pressure in all the directions in this case also. We have fast moving aeroplanes. Now, while the aeroplanes are moving, children, we have air pressure from all directions. But remember, the fast moving air is at a lower pressure than the slow moving air. So, the pressure above the wing, if you take here, the pressure above the wing is lower than the pressure below the wing. Therefore, what is happening? It helps. The pressure helps in the lifting of the aeroplane. Did you understand? There is pressure all around. But what is happening? The pressure which is below is greater than the pressure which is above the wing. That is why it helps in lifting the aeroplane upward. Is that clear, children? Okay. So, we know that air pressure is the weight of a column of air pushing down on an area. Now, we cannot feel it, right? Because the air is not felt. But again, children, you know how heavy the air is? It is as heavy as 3 cars which are acting on you. Now, assume that 3 cars are falling on something. What will happen to it? It will crush down, is it not? But the air is not felt by us. Why is it not felt by us, children? Because we have air pressure or we have pressure on inside our body also. We have pressure inside our body also. Now this pressure which is inside the body is matching with the atmospheric pressure which is acting from the outside. That is why you do not feel the weight of air. Okay, and moreover, all these air molecules push evenly in all directions. Suppose you are standing, there is atmospheric pressure on you, on your head, on your shoulders, on your legs from the below, everywhere, towards all sides and diagonally, towards your front, towards your back, from the top, from the bottom, sideways, everywhere there is atmospheric pressure all around. Now this is balanced. Therefore, you do not feel any atmospheric pressure at all. Now, atmospheric pressure acts in all directions. Now, look at this, children. Do you understand what this is? Yes, there are 2 glasses which have been stuck. There are 2 glasses which have been stuck. You have taken 2 glass tumblers and we try many times. They get stuck inside. Not only glass tumblers, usually steel tumblers also. They get stuck. And even though we try a lot, we cannot pull them. So we try different methods and we try to pull it out. That's a different thing. But why does this happen, children? This happens because of air pressure once again. Now, the pressure which is on the inside, you have air on the inside locked up. You have air locked up on the inside. And the atmospheric pressure is more, which is acting from the outside on the glass. Okay, when the atmospheric pressure is acting on the glass, see here, it is acting here. And this is very tiny. So, this atmospheric pressure is larger. That is why it does not come out. Is that clear, children? Let me show you one more example. You will clearly understand that. This is a suction. You know the bullets from a gun. When you shoot them, what happens? They go and get stuck to the door. Why does this happen? This happens because there is when it is pushed towards, when you push it like this, most of the air comes out of these spaces. Most of the air comes out of these spaces, and there is no more air left inside. I mean, there might be a little left inside, but very less amount of air is left on the inside. Therefore, it is locked. And again, what is happening? All the atmospheric pressure is acting on all sides. So, here, what is happening? There is atmospheric pressure which is acting from all the sides. Whereas to come from inside, there is only very less amount of air. That is why it gets stuck. And when you have to pull it out, what happens? It is very, very difficult. Did you understand, children? Yes? Okay. Now let us move on to the next topic. Can you see this, children? Look at this boy who's carrying. This is just showing that there is a lot of air pressure which is on your head. There is a lot of air pressure which is acting on your head, but still you do not know how much is acting on you. Okay, this weight of the air column is almost around 1000 kgs acting on your head. It is almost around 1000 kgs, 1000 kgs which is acting on your head. But you're not able to feel the pressure because the pressure inside our bodies, inside the body, is also almost equal, and hence the atmospheric pressure cancels the pressure from the inside. The atmospheric pressure is cancelled by the pressure from the inside. Is that clear, children? Okay. Now we have one more small thing. This is found by a scientist, okay, a German scientist, Otto van Guericke or Guericke. He found an instrument which can suck out all the air which is inside two objects. So what he did, children, he took two hemispheres. You know a hemisphere, half of a sphere. So this is one hemisphere and this is the other hemisphere. We have two hemispheres over here. This is one hemisphere and this is the other hemisphere. And with the help of the machine, he sucked out all the air. So, do we have any air on the inside? There is no air on the inside. Now, what did he do? He used horses. 8 horses on this side and 8 horses on this side to separate them. 8 horses on this side and 8 horses on the other side to separate them. But could they pull the hemispheres apart? No, they could not pull the this hemisphere apart. Why couldn't they pull, children? Because there is no air on the inside to act. If there was air in the inside, this air would be acting outward. Okay, if there was air on the inside, it will act like this. But here there is no air at all. That is why only atmosphere is acting. There is a large amount of atmospheric pressure acting in all directions. Therefore, they are going closer. From the inside, 0 because there is no air pressure. Okay, now. So, children, we have learnt about atmospheric pressure till now. Atmospheric pressure is the pressure due to the air which is present in the Earth's surface. Okay, right. Now, there is one more topic which you need to learn.